Equation of straight lines. What all we have studied in lower class, we are trying to recall. Given a straight line, we call the slope as m and y-intercept as c. What is the equation of the line? So we are writing the equation as y equals mx plus c. Equation of the straight line, when m is the slope and y-intercept as c, we get y equal to mx plus c. When one point x1, y1 and the slope m is given, y minus y1 equals m into x minus x1. Whenever 2 points are given, y minus y1 by y2 minus y1 equals x minus x1 by x2 minus x1. When x-intercept is a and y-intercept is b, we get the equation x by a plus y by b equal to 1. In all these cases, I find an x term, y term and a constant. So, the general form of a straight line, how do I call? Some x, some y, some constant equal to 0. So, I call ax plus by plus c equal to 0 as a general form of a straight line. Slope. How all I can find out the slope? The very basic idea of slope is tan theta if angle is given. If 2 points are given, y2 minus y1 by x2 minus x1. If an equation like this is given, slope will be minus coefficient of x by coefficient of y. As and when needed, we will use any of this formula. Angle between two lines, if the lines are like this, with theta, the angle in between, theta equal to tan inverse m1 minus m2 by 1 plus m1 m2. The angle could be acute or obtuse. So, treat the modulus to consider only the acute angle between the lines. When 3 lines are given, all are meeting at a particular point, I call the lines to be concurrent. The word concurrent tells me they all meet at a particular point. Concur, meeting. Condition for this, now that we have learned determinant in the very first chapter, concurrency tells me determinant equal to 0. What should I fill in? All these coefficients. X coefficient, y coefficient, constant of the first line. Similarly for the second line, A2, B2, C2, and for the third line, A3, B3, C3. X coefficients, y coefficients and constants. Find the determinant. If the determinant is 0, we can declare the 3 lines are concurrent. We have some more formula. Distance of a point L, M from a line AX plus BY plus C equal to 0 is, in this line wherever XY is coming, substitute LM. AL BM plus C divided by root of the coefficient squares. A square plus B square. Distance cannot be negative, so put modulus symbol. Length of perpendicular from origin to any straight line. The same idea we use. Now LM becoming 0, 0. So this is 0, this is also 0. I am left with C by root of A square plus B square. Here also we remember to put the modulus Distance or length cannot be negative. Almost all these formula we have studied in standard 10. We are just recalling before doing our 11th portion. Exercise 3.2, question number 1. Find the angle between the lines whose slopes are 1 by 2 and 3. Take the first slope as m1 and the second slope as m2. We know angle between the lines, call it as theta, and theta equals to tan inverse m1 minus m2 by 1 plus m1 m2. Substituting, theta equals tan inverse of 1 by 2 minus 3 by 1 plus 1 by 2 into 3. Tan inverse of, we are taking LCM, 2, 1 minus 6. Denominator also, the LCM is 2. Cross multiply 1 into 2, 2 plus 1 into 3, 3. Down I can cancel. Denominator and denominator we can cancel. 1 minus 6 is minus 5. 2 plus 3 is 5. Modulus is there. Negative number we can write as positive. Tan inverse 1. Tan inverse 1, recall from trigonometry. Tan theta 1 tells me theta is 45. So tan inverse 1, we will call the angle to be 45 degrees, or we say pi by 4 radians. Question number 2. Find the distance of the point 4, 1 from the line 3x minus 4y plus 12 equal to 0. Take the point 4, 1 as L, M. The line ax plus by plus c equal to 0 is given here as 3x minus 4y plus 12 equal to 0. Distance of the point, the formula, modulus of AL plus BM plus C by root of A square plus B square. So the distance is equal to AL, this is A, B, C. L, M. Just substitute. 3 into 4 minus 4 into 1 plus 12. In the place of xy, we put 4, 1. Root of A square plus B square. 3 square plus minus 4 the whole square. Simplify the answer. D is equal to 12 minus 4 plus 12 by root of 9 plus 16. 9 plus 16 is 25. Square root is 5. 20 by 5 we get 4 units. So the distance of the point 4, 1 from the given line is 4 units. Question number 3. Show that the straight lines are concurrent. Concurrent, we need to find the determinant. If determinant equals to 0, we can declare the lines are concurrent. So first step, write the lines one below the other. X plus y minus 4 equal to 0. Treat the right hand side to be 0. 3x plus 2 equal to 0. Y is missing, you can put 0y for convenience. 3x minus 3y plus 16 equal to 0. All the right hand side is 0. We will write condition for the lines to be concurrent. What is the condition? We said determinant. A1, B1, C1. A2, B2, C2, A3, B3, C3 equal to 0. Let us find out the determinant, the numbers 1, 1 minus 4. Second equation 3, 0, 2. Third equation 3 minus 3, 16. find out the determinant. Let us remember putting the symbols plus, minus, plus. Expand it. 1 into. Hide the first row and column. 0, 2, minus 3, 16. Minus 1 into. Again hide the row and column. 3, 2, 3, 16. Minus 4 into. Hide the row and column. 3, 0, 3 minus 3. Expand the determinant. 1 into 0, multiply, subtract. 0 minus of minus 6 is plus 6. Minus 1 into 48 minus 6. Minus 4 into minus 9 minus 0. Simplify the answer. It is 1 into 6 minus 1 into 42 minus 4 into minus 9, or I get 6 minus 42 plus 36, which is 0. Since my answer is 0, I can declare the lines are concurrent. So the given lines are concurrent. The only condition to remember, the determinant of the coefficients should lead to 0. Question number 4. If the straight lines are concurrent, find A. Given the three different straight lines, try to rewrite them by bringing constants to the left. So plus 13 will come as minus 13, minus 1 will go as plus 1. Here already it is in the left. Keep the right hand side to be 0 and check whether you have written x under x, y under y constants together. Condition for the lines to be concurrent, the coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3, the determinant should give 0. Substitute 3, 4, minus 13, 2, minus 7, 1, a minus 1, minus 14 equal to 0. As we expand the determinant, it is 3 into, hide the row and column, minus 7, 1, minus 1, minus 14. Minus 4 into, hide the row and column, 2, 1, a, minus 14. Minus 13 into, hide the row and column, 2, minus 7, a, minus 1. Multiply. Minus 7 into minus 14, minus 1 into 1. So we get 3 into 98 plus 1. Minus 4 into 2 into minus 14, minus a into 1. Minus 13 into 2 into minus 1, minus a into minus 7. As we have expanded, let us simplify. Minus 87a plus 435 equal to 0, or minus 87a is minus 435, a is minus 435 by minus 87, giving a value as 5, and that is the answer. Question number 5. A manufacturer produces 80 TV sets at a cost of rupees 2,20,000 and 125 TV sets at rupees 2,87,500. Assuming the cost curve to be linear, find the expression and cost of 95 TV sets. Whenever we are reading a problem which reduces to be linear, it is line equation. So we can treat one as x and the other as y. Here we are having number of TV sets and cost. Consider number of TV sets as x and cost in rupees as y. First line tells 80 TV sets. So this is 80. Cost is 2,20,000. That is y. Second line says 125 TV sets, which is X, and the cost is 2,87,500, which is Y. Point form X1, Y1, 80, 2,20,000. X2, Y2, 125 and 2,87,500. Since the curve is linear, the line equation with 2-point form we can remember, which is y minus y1 by y2 minus y1 equals x minus x1 by x2 minus x1. Substituting y minus 220,000 by 287,500 minus 220,000, x minus 80 by x2 minus x1, that is 125 minus 80. Simplifying this answer, y minus 220,000 by 67,500, x minus 80 by 45. Cross multiplying, y minus 220,000 equals 67,500 into x minus 80 by 45. Cancel 45, it is 1,500 times. Multiplying and bring minus 220,000 to the other side. So 1,500 into x is 1,500x minus 1,500 into 80. We get 120,000. Minus 220 comes to the other side as plus 220,000. Simplifying this again, we get the equation as y equals 1,500x plus 1 lakh. As I have got the equation, my question is, find the cost of 95 TV sets. So to find the cost of 95 TV sets, put x is equal to 95, find y. In the very first case, we have taken TV sets as x and cost as y. So in this equation, y equals 1,500 into x value 95 plus 1 lakh. Simplifying the answer, we get y is equal to rupees 242,500. So 2,42,500 is the cost of 95 TV sets.